Yes. Okay. Testing. Yankin, can you all right, hear me loud and clear?
Yeah.
All right. Cool. Must be in your house. All right. Cool. All right. Okay. Looks good. Probably ask you to zoom in. Yeah. Yankin, it's still in portrait mode. Could you make it? Right. Yep. There you go. Yeah. Oh, not yet. For some reason. There you go. All right. There is one extra thing I asked you to do, which has something to do with the aspect ratio, which I haven't sent you. My goodness.
Yeah.
Right. Okay. So I'm gonna send you using the WhatsApp.
Yeah.
Yeah. My mistake. Okay. Never mind. You'll do it after this, right? So not to waste time. Okay. All right. Yep. This is good. This is good. I can see it. Please zoom in. Okay. Looking great. Excellent. Okay. Right. Okay. So we're trying out in a room. You're using a headset, right? And you have chosen chemistry, right? Okay, right.
I mean, I could do any other subject. I can also do math.
That would be nice. Before we do that, right? So after watching the recording last Monday, right? So I realized it is possible that you already heard like what 80% of what I explained to you. Right, I don't know the areas and everything. Right, that's my impression. Right, when I rewatched our recording, is it correct?
I watched 80%.
Like when I explained to you all the stuff, maybe there's something new, but most of them you know or you understood already. Am I correct?
I think so. Yeah.
Right. Okay. Now, I appreciate that you don't stop me from explaining. However, I need to know why you don't stop me.
I mean, I mostly think of it as like good revision. You know, like I know it, but I won't like it won't immediately come to me if someone asks me. You know. So it's more of like remembering like what this term means, like what this term means and how and what's like and like how the reaction works and all this other stuff. But obviously, once you bring it out as like an idea, right? But when we go through it, then it's clearer, you know.
Right. Okay.
Because like, you know, I haven't thought of the things. I haven't thought of like everything in a while. Yeah.
Right. Fair enough. For math, I want you to interact with me, so that the explanation can be shorter. But that's not the point. So the point is that you should be more confident in what you know. If you're rusty, then of course, maybe you should review before. But for today, I want you to just be a bit confident with what you think you know. And then we can focus on what you do not know. That is, I think, a very important part, right? If the line is very blurry, we will not reach, the parts that you actually don't know, right? So that's our balancing act, right? We don't focus too much on what you know, even though it is our more comfort zone. Okay. So you chose math, and may I know why?
Well, I haven't done integration in since like schools ended.
And
like, I think, and like
Yep.
there are some like when I was trying to be like when I tried to be during like holiday, like some of the revision questions.
Yeah.
I was like all of everything like here
Mm-hmm.
I did already. So like
Yeah.
I did it like before school ended. But then when I tried to when like after I took like a long time not doing anything, that I just came back here. It's like
You mean, sorry, when you say, sorry, when did you do that? When did you do the intermediate one?
like all
Before,
this, right?
Yeah,
All
before
the
school
intermediate
ended.
advanced before school ended. I finished everything already.
Right, yeah.
Then like here as well, whatever. But then when I come back here, right, all the review problems, right, then I get stuck,
Right.
It's like I feel like I shouldn't be stuck, but I am.
No wonder. No. I mean, what you're experiencing is not new. Tell me what's going to happen, next week. Are we going to do integration next week, or what's going to happen?
Well, I know that Canberra going through some period. What I told you on Monday, a periodic table, that kind of
Yeah.
thing.
All right.
Physics, I think we're gonna continue EOEDC.
ICDC, you're saying? Sorry.
Yeah.
All right.
I think it's alternating current.
Okay, sure.
But then math, I'm not sure what we're supposed to be doing.
So this is like the last lecture note and tutorial before school ended.
For year one.
Have you been tested on this?
No.
Right. Okay. So you don't have any other lecture note besides this, right?
Yeah, I don't think so. No.
Okay. So let me say very briefly a few topics that I think will come out, just to make sure that you haven't studied or learned about them, right? Okay. So in O level, you've remembered this, we will calculate the area under the graph. We will need integration. So far, so good. Okay. Then in A level, which is now after this integration by parts, usually you will go to the application of integration. So this is like pure integration. What's the application of integration? It's just an upgrade of the area. It's called a volume of revolution. Ever learned that before?
Volume of what? Evolution.
Revolution. No, revolution. Yeah.
No.
Right. So definitely, yeah, that's one. And then no, not that also. Basically, the application is not a lot. So that would be it, I suppose.
Application of integration.
Yeah. Application of integration is not a lot. Application of differentiation may be much more.
Yeah, I think I already did application of differentiation.
Yeah.
If that's all there is to do, but like there was already a chapter called application of differentiation for me.
Right. There's quite a lot, which is application. All right. So you'll be doing that, I believe. And let me just remember a few things. So you have done your AP-GP, your Maclaurin series, right? Done?
Yeah.
Okay. Then you did your what we call the complex number and vectors.
Complex numbers.
Maybe not.
What complex numbers?
Okay. Then
what do you mean by that? Sorry.
Let me quote another phrase: Argand diagram.
Okay, never mind. No.
Okay, then definitely not. Okay. So you have done complex numbers, so that would be it. You have done your vectors, first thing.
Yeah, the first chapter.
And then you have done. Integration is a big part. You have done the transformation, the graph. There isn't much else. You're basically doing almost everything. APGP we did.
Yeah, APGP.
Yeah, definitely. So after the application of integration, just a small part, probably your calculus will end. And then, so this is the hardest part of integration here right now, integration by parts. And integration. So the pure integration is hard. The area of revolution is not hard. It's not hard, right?
Okay.
So then you have your complex number, and then you enter your statistics about on schedule. On schedule. So what should I do? Fine, fine. We'll do this. We'll just do a quick revision of this one. Set a timer for 0:30. Right. So instead of just helping you revise, we'll talk about the habits, which is very useful. So you have your, for example, you have your working of the previous questions, right, with you. You have it, right?
Yeah, I have to look for them, but I'm pretty sure I still have them.
Take them quickly. Yep, please.
Wait, let me think. Do I have that or did I give it back actually?
That can.
Let me check. I don't think I have some here, but most of my, because I did corrections at the end of the year, so
Let's do the correction one. That's fine, because we're just using this to.
Okay, it's not the complete version.
No problem.
There's a lot of like all this stuff here.
No problem.
It's not a complete version, but I have.
Right. So you're gonna help me. You're gonna help me. No. Okay, I'll see your working only. So let's start from what you have. Right, what you have is here. So okay, good. So you don't need to see. You don't need to show me the question if you already have it in your foolscap. Okay. So let's say question 10. Right. Is the question supposed to be? Right. Okay. So the derivative is easy, right? Done.
Yeah.
Then the integration of that thing. Okay. So you're gonna cover your working, please. Cover your working, especially on the integration. Use a piece of paper. You'll be needing your pen. Right? Easier. So just cover on the integration. Right. So no, you should be covering down. You should be looking at the question. Right? Okay. Yeah. Go up. Go down a bit. Go down a bit. Yeah, that one. You just see that one, right? Okay. So I'm going to revise the principles with you. We go high level, meaning we go more of the concept, because I feel that that will jot your memory better, right? Let's see whether that's true, right? So why did they ask you to do part 1 before part 2? What could be the reason?
Because like I assume it's gonna appear inside the. If I like change x cubed cosine x squared, it will just appear. Like then this one will appear inside. Then I'll just like convert it back up to the original.
You know that this chapter is what they call reverse product rule, right? Right. They shorten the hint as Liate, right? Like you decide who is the U and you decide who is the DV, basically, right? Am I making any sense? Sorry.
Yeah, I think so.
Right. Reverse product rule, right?
It was.
You have to choose a U and a DV.
There was like a acronym, right?
LIATE to help you choose, right?
Yeah.
Choose, but for example, the acronym will not be helping you directly. If acronym is all you need, then it is going to be straightforward. Always rely on Liate. Yeah, but by your experience, you know that you need more sometimes. Am I correct or am I jogging your memory somewhat?
I think so.
So if you consider
simple convert, because like I don't know, I'm pretty sure there will be special cases.
Yeah. So what you're looking here, just make a quick guess based on your feeling, right? I'm totally not seeing your video. Like you're gone. Your video's gone.
Oh.
Yeah, for some reason.
Is it back?
And now I think your handphone is acting, right? Because he returned back to portrait mode. This happens a few times with some other people. So it's very weird. That is back. Okay, thank you. Right. So this happens. So I suppose
yeah, okay. I'll just be careful next
time. I just tell you. Okay, so looking at part one, especially, right? Do you think this is going to be special case or Liate is what we can rely on? What's your gut feeling?
Special case,
And
definitely.
and that part one is the special case, most probably big hit, right?
Mhm.
Big hit. So can you describe to yourself how part one will help you?
I assume I'll have to find part one in part two. Like obviously there's already like cosine x squared here.
Yeah, and then there's a, but you need the exact one, right? Exactly.
Yeah, so there's no 2x.
Right. So just be very quick. This part one, 2x cosine x squared, which you can find in part two, that guy, is it going to be dv or u? Am I making any sense?
It's gonna be, wait, let me think.
dv
I want to
or
move up. It's gonna be dv.
I agree with you. So please split into the u and the dv. I think that is our basic first step. By our experience, we will try to set up the u and the dv. Am I correct? That's what you need to do. Okay. Okay, good. So who is the u, right? You need to set up that, like, who is the u here?
So this is obviously 2x cosine.
So the v will be, view of that, right? That's fine. So if that is the dv, then what is the u?
I have to come out of. Yeah, but the problem is converting.
Oh my god.
Taking out. Wait.
This is too slow. This is much slower than I expect.
X
Yeah. With the dx.
Yeah, I need 2x, right? So
yeah, you need the 2, not the 2x. You need the 2
because
the x is done. So
So
all you have to do is
square times
to put
x,
it.
so it's half r.
Yeah, half. Because half times 2 is 1. Simple, right?
Okay.
By the way, where's the dx? Oh, the dx is there. No, you're there. You got the dv dx. Okay, so the du will be, the du dx will be?
The du dx will be x.
Go ahead. All right. Now, let me ask you something. Just by your, now is your imagination, your mental ability to predict the later steps. Do you think you are done thinking this is now simply doing? It's going to be easy, or is there something else to think about?
I think it's just doing. I think once you reach the step where you can establish.
So basically, you're saying that you're happy with your du and v.
Let me think.
Right. Yes, please think.
Okay.
How come you're happy with the u and dv? How come?
I think there was my teacher was talking about a case where it was like it kept repeating itself and you never reached like a, because there's an integration. Yeah. Once you rephrase it, right, it becomes there's an integration inside and it will just repeat.
Okay, so, then let me jog your memory again. Of course, you're talking about a past experience. You're predicting that this may be repeating. You're predicting. Yeah. Okay, let's imagine without you looking at the working. Let's imagine the integration of u dv, right? That's how we start, right? This is it, right? Is going to be equal to uv. Am I correct?
Integration of u dv.
dv.
Yeah, okay.
Is uv, which is uv giving you trouble?
I don't think so. I mean,
because you have the v.
Yeah.
That's the reason, because you have the v. So uv is not. So the only thing you have to worry about is the other guy, minus integration of v du.
dx and
that thing. Okay, so that is where you focus your energy without doing anything. Can you integrate x sine x squared? Can you integrate it?
Yeah, I just do another integration by parts.
All right, can you focus on that? So you have x sine x squared, and then you don't open your working. So you have very little space to work with. This is my design, and please tell me how you solve that.
Oh, okay, wait, give me a sec. So I have.
So you just write integration x sine x squared. That's all you write. That's all you focus on with a dx, of course, which I cannot see. So go down a bit. Okay, thank you. So how are you with the dx? So how are you going to settle this? Is this an
LIATE? So
okay, sure.
T is trigo, so
L is
wait, so it's x and then sine x squared. Okay. So
Oh man, oh, I want to scream. Okay, you do you. I want to scream
wait,
quickly.
um,
Yeah, you do your Liate lah. So you're predicting that Liate will be reliable here. Okay, let's see lah. So who is your you?
it will have to be
What is Liate? Sorry, let me just.
I'm gonna be honest.
Did
I
your
only
teacher
know.
teach it as Liate? Did your teacher teach
Yeah,
it?
yeah. It's
Okay,
right here.
then which one do you remember? You can go and look at Liate. So what is L?
L is logarithmic.
All right, sure. Which doesn't exist here. Then
I is inverse trigo.
which does not exist here.
Yeah, A is algebra.
Which exists here.
Yep. And then
Okay.
trigo.
Here you go. Which exists here. Then
Yeah, and then exponential.
right. So algebra first, then trigo. What does it mean? Algebra first. What is first?
So algebra will have to be the U.
Okay. So another U would be your X lah. So I was because you're hesitating a lot when you have decided to use Liate. So I was wondering why. Right. So go ahead. Go ahead.
Okay, so
Yeah, you probably wouldn't like that at all, right? So the
Yeah.
U dx is easy, right? The problem is how am I supposed to integrate sine x squared? That's the problem. Immediately you realize the problem, right? This is like, wait a minute, my DV is not working, right? Or can you? If you can, then I mean, obviously your problem is done lah. But can you?
Nah, not really. I don't see a.
Right. So at this point, because I feel this should be part of your experience or feeling or sense, but I feel it is missing. It has been missing in quite a number of students, and I do not know why. Whenever I see integration of x sine x squared, this is the thing I think about, and I find it to be straightforward. For most students, it is not. Now, what I'm thinking here is not Liate. It's not inverse product rule. Yeah, it's not. So now, how do you want to see my working? Is it by looking at your screen, or is it by looking at laptop?
I don't have a laptop here, so I guess I'll look
so
at
right now we'll try looking at screen. So or rather, in your Zoom, right? Can you exit and just enter Jamboard? That might be a slightly better way. Let's try it. Yeah. Right.
Can I enter Jamboard? Yeah, I guess I can.
You probably can. And your Zoom will freeze, which is not a problem right now, right? Because I don't need to your Zoom for now lah. So I'm just going to make it for you, right? Okay. And today is 2022, right? 220105, right? Bam. Okay, sharing it with Yankin. The master key. There you go. Okay, tell me that you can see that. You can see it or not. You're looking at Jamboard. I'm sharing you Yankin.
Yeah, I see it.
Okay, so you open the Jamboard instead of me sharing screen. Okay,
yep.
Good. So tell me if you're seeing something. So your problem is this, right? Or rather, that's not your problem. Your problem is how to settle this DV, right? That's the problem, right? Right? Now, I see things very differently. I see this, which is that caught my attention immediately, right? Because it's not sine x, it's sine x squared. It's a problem. Imagine if there is sine x, then no problem.
Yeah, much easier.
Right. Okay. So when I see this, I immediately compare it with that, and I am very happy. This is what I notice is missing to most students, right? So when I see x dx, I immediately realize that that is definitely this lah. That is definitely half.
No.
Okay.
Yeah.
Now, what does that? How do you read this? Just so that we have the same page, because some teacher like this, some allow this, some teacher dislike it at all. I'm not sure why. So this simply reads the differentiation of half x squared is x dx. Right.
The differentiation of half x squared
is x dx, right? When you differentiate x squared, you get 2x times half x, no? So x dx lah. The dx used to be here lah, right? So now the dx is here. Simple, right? Remember, this is basically O-level stuff lah. It's O-level stuff. O-level basic integration. Let me repeat this. I can see it not because I am very experienced, not because I'm as sharp as a Japanese knife. It's just O-level stuff, basic integration. I'm confident that you can understand it almost immediately. Okay?
All right.
Why is this a big deal then? Because this is that. So, right? You know that the half doesn't matter, right? The half can simply go out, right? So I'm going to focus it on this one, right? Okay.
Yeah.
Okay. Right. So sine x squared, the problem guy, the one stopping you from doing the other thing, the x squared, right? With the half outside, the half is there. So we don't care about the half, right? Finish. Okay.
Half sine square dx square. Okay.
Right. The half is here, lah. The half is here.
Sorry.
Sine x squared is sine x squared, and this is that, right?
I'm not. Okay, I'm just gonna be a bit messy.
Yeah, please
but
tell
I'm
me.
not sure. Like,
you can simply use your laser pointer. You can simply use your laser pointer. No need to write something. Just use your laser pointer in your.
Yeah, I'm not sure how like the dx ended up here. So is it like here d dx, d over d dx, then you move it here?
Again, so yeah. So how you want to see it is like this, look. Perhaps like this. D dx equals to x, right? That's how you want to see it, right? Perhaps.
Yeah.
So therefore, this is correct, right? Therefore,
you can just move it like that.
You can always move it. This is a really simple division. It is division. It is. Oh, you're going to cover ODE. You haven't covered differential equation. That is your other application or integration. When you cover it, you will see them treat the x as a division because it is. I will be vindicated that way. Look. The x is just an integration. It's just a division. So I can treat it this way. Okay? You will see it very soon. Very soon in the next subchapter called differential equation. Right? Okay. Okay. So this is therefore that. All right. So this is therefore that, just to make it simple. Okay.
All right.
So therefore this, which is that, is now this thing, right? Therefore, okay. Okay.
Okay.
Just focus on the fact that this is still the same. The problem child is the same. I am not attacking the problem child at all. I am doing something else, right? Which is a very...
You convert x dx to
dx squared with a half, which the half doesn't matter, right? The half can just sit there. Wait, nicely.
Okay.
This matters a lot. This and this now matters a lot. Now look at how I do it. Look at how I do it. See whether it makes sense or not. Which is therefore half, again, half, right? Half. Oh, this is going to be very easy. This is going to be, of course, minus cosine x squared. Done. Of course. That's my claim. Yeah. And, you shouldn't believe me. You shouldn't believe my claim just because I claim. You should simply prove me right or wrong. How do you prove that my integration is correct?
I mean, differentiate, but that's not a good way to go about it.
No. That's the best way. No, that's the best way.
Yeah, but like that require me knowing that, knowing that moving down here will give me cosine.
No. You skip this. Who asked you to do this? Just differentiate this, you get this back. That's my claim.
Okay.
Right. So you go back to your Zoom. Let me see how you work. You just do it on pencil, on paper. Right. So flip back. Your video is off. Let me see your video. I'll repeat my answer. Right. Okay. Good. So my claim is it's minus half cosine x squared. That's my claim. So please differentiate that and see whether it works. So,
so cosine, negative cosine is sine.
And negative. Oh yeah, correct. Yep. Yeah. The half should the half is just up. You should do that by habit. It's a good habit in exam. Half shouldn't be up. So you will get sine x squared with
sine, sine x squared, then 2x again.
Then 2x, right? Okay.
So
Then,
it's
right.
half
Right. Sine x squared, 2x, right?
sine x squared times 2x.
Yep.
But
And which is simplified as
x sine x squared.
so my claim is
Correct.
yeah. Okay. If you find this to be weird or new, which is I find that to be very weird, all the student I teach, how come you guys don't see it this way? Every time I try to explain it, you guys will inadvertently refer to a formula, which I really hate. I feel that really stops you from looking at things. But after some grinding, some student go, yeah, I understand the formula. This is the formula I was taught early on, something. Right? Now, which one are you interested in?
Let me try back to the Jamboard.
Yes, you can look at the Jamboard right now, and you can ask questions like how I do it. Which part is confusing?
What happened to the
This must be the confusing part, no?
Yeah.
So how I see it, how I see it is this is x squared and this is x squared, right? Correct, right?
Yeah.
So how I see it is this is a u and this is a u. I can just pretend that x squared is u, so both are u, correct?
Yeah.
And therefore, this will be minus cosine u, correct or not? Isn't the integration of sine u du
What happened to
minus
du?
cosine u?
Like, what happened to the d in du?
Okay, when I ask you to imagine this as u and u, basically, y or y, u or u, x or x, they are the same. That's the most important thing. Sine u du is in the context of u, so to speak, in terms of. So as easy as if this were to be sine x dx, I know it's not, yeah? As easy as, however, if this is sine x dx become minus cosine x, sine u du becomes minus cosine u. Ta-da! As easy as that. As easy as that.
Let me think. Wait.
Yes.
So,
sure.
So the original equation is sine x squared dx squared, right?
That's the intermediate step, which I introduced, which I think is a big deal, right? So the big deal is that this is u and this is u, and you see the whole thing, no longer any x. I successfully migrated from x to u, successfully, totally. That's key. That's key. Once I can do that, there is no more x to be concerned. I can migrate to u totally. I can immediately see my result as minus cosine u.
Then
again,
change back to x squared.
And then I just change back to x squared. Right? That's the first thing I explained. Now let me explain further so that you're satisfied. I'm trying to make you satisfied with this approach because this approach is extremely quick, on par with if you grind the formula, right? If you want to do that, if that's your thing, you grind, okay? But give me a chance. This is reverse chain rule. I am reversing chain rule. Okay. Notice what you do when you differentiate this. When you differentiate half minus cosine x squared, you end up with, half sine x squared and the differentiation of x squared, which is 2x. That's what you did, right? Your differentiation step is I see half minus cosine x squared. I write half, right? Sine x squared. Correct? And then you write 2x. How do you get 2x? That's the differentiation of x squared. Right? Okay. And then you come up with this. No? So your step is just bong, bong, isn't it? Correct.
Okay.
Yeah, so I just reverse the step.
Okay. I suppose that makes sense.
Yeah, and I will suppose that you trust me a bit, it is going to be very fast once you see these things. Once you simply learn to see it that way. I am just reversing chain rule. Remember that. That's all I'm doing. The same way that they teach you, I can reverse the product rule. Okay? Liate, reverse product rule. This is a reverse chain rule. The two most important rule in differentiation. I will just reverse it. Okay.
All right.
Now, I want to sum this up. This is the best way I know how to solve this problem, the x sine x squared, because the Liate is not helping you. Secondly, I don't consider this a special case because I can see it. You may want to consider it a special case. Anything, as long as you understand this method. Once you understand this, only then you are allowed to see your previous working. You might be surprised. You might be surprised. Okay, do you understand this approach? If you're comfortable, show me a video which is gone again for some reason. And
Yeah.
because of Jamboard.
Yeah.
And then if you're comfortable already, you look at your previous working and see whether it makes sense. Kindly help me zoom in because it kind of it's zoom out again. Okay. Okay, right. Oh, I see a U, which looks very. Oh my goodness, it looks very complicated.
Yeah, I might have been wrong. I don't.
It looks superbly complicated. Look. Our result just now needs to be returned back to the original product rule, right? The original Liate, right? Right. So you close your working again. You close your working again, and you're going to now finish up the second Liate lah, by using that thing just now. So now you can write down the V, right? The V is now what? Just now. Yep. Go ahead.
Oh, this is a lot.
Du dx is 1.
1.
Right? Done. Okay, that's clear. Now, what's the V just now? You're integrating. Oh, apologies. I'm so sorry. You're not supposed to do this. You already know the integration of x sine squared. I'm sorry.
Oh yeah, it was
cosine. Was it what just now?
Half,
minus, right?
Minus half.
Minus half cosine x squared. So you just write it down so that it's easy to process, right? And then you're just gonna please, erase or whatever the second Liate,
so
right?
Minus, and then the original was UV.
Yeah.
So it's half x squared sine x squared.
Yeah. Minus this log, basically, done, right?
So it'll be
right. So you're gonna compare that with your final working. I think they are the same. I think your final work last time was just to combine these two. I think. Yeah. I don't know about that. That's the cosine x squared, right? Not x cubed, right? That's a cosine x squared, right? Yeah, correct.
Yeah, that's x
squared. Look. You assume that the x squared is U. That's what you did. Don't know how you did that, but that's what you did.
See, I thought it was wrong.
Yeah.
My teacher, I don't know what teacher did differently. Because like this one is what I put it. This one is like it was like a sort of like a draft as I was learning. I'm pretty sure I had like a longer sheet of paper with like all the answers.
But now you have a simpler way of understanding it. At least I hope. Right?
Okay. It's gonna take a while to like get it, but like.
Oh yeah. Once you accept it, I'm gonna force you to do the reverse chain rule until you simply get it. Because I think that is the best way. Either that or you grind. Either that. The worst option is you consider this a very special case. I don't think so. The way you do it first, this one looks much more complicated than necessary, is what my feeling is. It is presented very well. Let me just say that the way this is presented correctly. That's why the answer is correct. We could have done it much easier, much more easily. Correct? Okay. Any questions so far? You have many questions, but anything major other than you have to digest this?
Yeah, I think I'll have to.
Right. So I'll leave that to you. But I am strongly proposing that starting now. Now, why don't we still have time? Why don't we do the same process with question 11? In a sense that you're going to close, you close your previous working, and then we're just going to figure it out without doing it, right?
So
Which I need
11.
you to shift up. I need you to shift up. Right? So the differentiation should be easy lah. Let's just consider that way. Okay? Differentiation done, right?
Yep. So
that looks
it's
very complicated. Why is the differentiation very complicated? Oh,
can you see the
okay,
question?
Yeah. Not sure why you didn't stop at the second line, but I'll follow. Fine, right? So
Oh,
you
I
kind
just
of like,
thought I had to, you mean stop here?
right? I do, yeah. So at this point, I don't know because that will depend on the context, right? Which is the part 2 lah. So I don't know whether you're doing the useful thing or not. But
Oh, I just try to simplify as much as possible.
correct. I feel that you don't, but you know what? I can be wrong. Right? Okay. So let's just check it out. Let's just check it out. The bottom part, which is part 2. Right? What's part 2? So part 2 is the thing that we're
Part
doing
2
here, right?
is.
Hence, find
Let
that,
me
right?
just write it.
Yeah. So you should just open one line and see whether you wrote it, right?
Yeah.
All right. So let's just use that, right?
Sine inverse.
E to the power of 2x, right? Oh my goodness. I just saw.
What?
I just saw an easy way to do it. What's going on here? I don't know why it hangs. Okay, what's your idea? How do you?
I don't. Let me think. Obviously, we have to find this inside here somewhere. I was thinking, what is the differentiation of sine inverse x?
Yeah, you probably want to think about it, and you probably don't want to remember it. You can just look at those things are not to be remembered. You can just check lah. If you want to know what's the differentiation of sine inverse x, just check it out, right? No point remembering it, right? You gotta use it. You don't have to remember it. Just refer to it.
Yeah, give me a second.
You need the page quickly, right? Which is that's what's bothering me right now. Right? You don't know where to flip. Right? That one.
Well, it has been a while. Actually, I don't really think it's on this.
I think it's earlier than this. Sine inverse x differentiation integration is discussed very early, very early. So like maybe.
Oh, I don't even think it's on this. It's on this.
Yeah, I don't think so. Yep, precisely. I think it is. Before this lah.
Okay. I'm just gonna. One sec. I wrote this down. Question 9. Sine inverse x. So the differentiation of sine inverse x is 1 over root 1 minus x squared.
Right. Right. Okay. So that I think that's probably going to be helpful. Good. Yeah.
Okay. Let me think. So what did you do just now on Jamboard? Let me check. Give me a second.
Right.
Oh man.
So let's call this process inverse product rule. Okay. Inverse chain rule. For lack of better name. Okay. Inverse chain rule. Right.
Okay.
So are you saying that maybe you're hoping inverse chain rule will help? Because you're saying that means you're saying that Liate might not be the best the best option right now lah. That's what you're saying basically.
I mean like I feel like we could try the new method,
Inverse chain rule, right? Inverse chain rule. So the process of inverse chain rule, let me just reiterate one more time. The best way to explain this is you're replacing all the x's with something new, which is u. The u can be anything you want. In this case, in our new case, the u, to help you a bit, the u is probably going to be e to the power of 2x. Probably. That's going to be helpful, right? So look at the Jamboard. So I am making a guess. You must understand, Yanjin. I am making a guess. That is, I think, the nature of the things. I'm guessing that the u will be that. Okay, Ken? That's my guess.
Are you on Jamboard?
I am on Jamboard, page 2.
Page 2. Don't see anything.
It should be. I have written something on page 2. No?
Give me a second. Let me go back inside. Give me a second. It's loading.
Sure. There you go. I think you're in.
Yeah. Okay.
Okay.
U equals
So, yeah, the best way to describe what I'm doing is I am, because sine u will be nice lah. Sine e to the power of 2x is not nice at all. Sine inverse e to the power is not nice, but sine inverse u might be nice. That's all I'm basing it on. So far so good, Ken?
Okay.
Yeah. So now, by this guess, it looks like I'm doing something different from just now. I'm leading you towards an easier road. So what is therefore du dx? What is du dx?
E to the power 2x times 2.
Good. Right? That's the easy thing. O level, again, O level. So this is a conclusion of that. Now I'm going to rearrange. I'm going to rearrange everything. So du is going to be e to x to x, right? I just rearranged because it's a simple division, right? Okay.
Okay.
Right. And then I'm already seeing this in your question. I'm already seeing it. Right?
Oh.
Right. Which is now this is half, right? Right. See. You see that? See what I'm saying?
Okay.
The moment you have this guy, which is a guess, but then you have this guy. That's what I'm trying to do to confirm whether my guess is useful or not. I think it's useful because now the question will be what? Integration of, right? Integration of sine inverse u, right? It's going to be that, right? Du with a half, right? Which looks easier. So I suppose we can continue along this path. We are nowhere near the end, right? But this seems easier.
Yeah, definitely.
Would you try processing this first? Because we still have to confirm. We are still in the realm of guessing. Do you understand what I'm saying? We are still in the realm of guessing. We still have to see whether this works. So please, your paper, try to do this. We are not done.
Give me a second. Let me put it down first. Yeah. Is it there?
Yep. Zoom in, please. As per usual, that's okay. This is the trouble. Okay, good. So once you change it to u, hopefully you can do something about it.
Equals to
half, right? Half sine inverse u du. You can work out the details later. The question is, is this going to help us move forward?
let me think. That won't really. I mean, like, isn't this okay? Correct me here if I'm making like a mistake, right? But half sine inverse. No, wait.
The half doesn't matter. Half doesn't matter.
Yeah. Let me think. Is there? Okay. No, never mind.
Because like, if this is sine inverse x dx, right? If this is sine inverse x dx, what would you do?
I mean, like, obvious answer will be integrate, right? But like, I don't think there's a general formula for integrating sine inverse x. Like,
there's only differentiation of sine inverse x.
Yeah.
Which is totally noted, right? Totally noted. But
I'm asking, like, if I did know the integration of sine inverse u, would this?
Then you're done lah.
Yeah, then
Do
that's
this
done,
be
right?
is done. Yeah, is done.
Okay,
But
okay,
you don't
okay.
know lah. But you don't know. But you don't know. So
Yeah, because like
what can we do?
because I was
Yes.
I was confused on whether like this du and like this d and this d here were the same thing.
One is dx, one is du. But the
Yeah,
important
but
is
they still mean the same thing. It's just that
yeah,
they're referring in respect to different terms, right?
yeah. One is in terms of full u, one is in terms of full x. So
Okay,
they are processed the same. They are
okay.
processed the same. So how do you solve this mystery of integrating sine inverse? Because you know that you don't know. How am I supposed to integrate sine inverse? Right?
Jeez.
How am I supposed to process this? Oh man,
Wait, what? Wait, I actually don't know. Wait, let me think.
You didn't even try to apply Liate. That's my concern.
I
At
mean,
least try
but
first.
isn't it like 1 times sine inverse u?
Look, again in Liate, you have to decide who is the U and who is the DV,
The
right?
u will be li, so it'll be sine inverse u. So
And if that is U, right? So okay. So it's very confusing because U equals to sine inverse U. So maybe can you just write W instead of U? So that it's less confusing. So what is dw du lah, not dx du. So would that be
1
doable?
over
Of course it is lah.
1
Of course it is
minus
doable, right?
u squared.
Yeah, of course this is
So
doable lah. So now the dv lah, what's the dv? The the dv dx. The dv dx is the dv
dv
du is du
1.
lah, right? It's
1
one,
and
sorry,
then
it's one, of course.
v
So
equals to
then
u.
the v is 2. Okay. So does this solve the problem potentially?
So
Does it?
like that down here.
Let's see lah.
So u times sine inverse u minus integration of this one, which is just
Yeah,
sine inverse u.
this. No. The integration of that times v, you know.
Oh, this times this.
Yeah, so not so straightforward. Not so straightforward.
Okay.
Solve the problem. Does it solve the problem or not? Right? Can you solve that problem? Can you integrate u times that?
U times this. Yeah.
Your answer is you can or you can.
I don't think I can't do it straightforward.
You can. I guarantee you can. Yeah, with the same process again. Look at your above problem, question 10. Your problem is x sine x squared dx. Focus on the problem. X sine x squared, right? That was your problem, right? Yeah. You don't know how to solve that. I propose that you think the problem to be x squared. I propose the x squared inside the sign. I propose that is your problem. Right. So you solve that problem. Basically, you try to solve that problem by using inverse chain rule, by basically making it to sine x squared dx squared. So I'm saying that maybe you can apply the same thing here because it looks like you're facing a similar kind of problem. Why? Because there's a u square there, right? There's a u square there. And then there is a u also lah.
U on top. Wait, can I just write it out? Like, this is going to confuse me.
Yes. You can definitely do that. So your problem is, sure.
It's this part, right? So it's
right. So is that
u
integration of u times
1
over. Right. So how am I supposed to settle this lah? If I couldn't, then this is a dead end loop. Fair enough lah. Fair enough.
What would be close the way? Let me. Nah, but I already did that. Is there any way of this factoring?
Yeah, I
Any,
know the answer. I'm not going to torture you. I'm going to use this opportunity to demonstrate the power or the confusion of this new method. That's totally up to you lah. Is it powerful or is it super confusing? Right. So I'm just telling you, I'm going to apply this new thing again. Okay. So please refer to my Jamboard. Please refer to my Jamboard. First of all, I hope you're not. Yeah, the alarm just sounded.
I'm not what?
No, the alarm was in my side. Okay, then that. Okay. So that's just half an hour. Okay. So I'm going to still page 2, right? Are you at page 2 with me?
Yeah, page 2.
Your problem is currently u that half 1 plus u squared
1
du,
minus.
right?
Isn't it 1 minus?
What do you mean 1 minus?
Isn't sine inverse? Isn't it 1
No,
minus?
I'm not writing the sine inverse. I'm just focusing on the problem. The problem is this guy.
No, like isn't it u times 1 over root 1 minus u squared?
Oh, minus. I'm sorry. You're absolutely right. Sorry, I get it. My memorization is okay. Something like that. Okay.
Okay.
And so if only I have this, my problem is solved. But obviously it is not. Yeah. So I'm going to not do the normal stuff, which is this. This is normal. I am going to now say that I'm just simply going to focus on the fact that this and this u du. I hope you have guessed it already. This is going to be half du square lah.
Sorry, my phone turned off.
Okay. Patrick?
No, yeah, I'm charging it now.
No, it's not. But because I can still hear you.
Yeah, I'm charging it now.
Good. So tell me when you can see it.
A minute. Can I do that? You convert the u back into
u du into that. So just the same process. Just the same process. Okay.
You convert u du into
half du square.
Oh man. Okay.
The differentiation of u square is, come on, go with me. The differentiation of u square is
2u, I guess.
2u times half is u. Yeah.
Wait, so du is just means differentiation of u square?
No. Du is the differentiation of u. That's it.
Oh, sorry.
No. U du, not du, you know. Du is not this. No. U du is half du square.
Okay, oh man.
Try your best.
U du is
half du square.
Oh.
How do you read this one more time? The differentiation of u square is 2u.
Differentiation of u square is 2u, yeah.
This one, so half times 2u is u.
Yeah, that part I get. It's just the
with du.
It's just the other way around, you know, like going from u du to.
Yeah, precisely. And I'm telling you, get used to it. The alternative might be worse. So far, it has been worse in question 10. You still have to do some sort of u thingy, and the way they present it is worse. Right? The alternative could be worse. Okay, right? Can you at least accept first based on the fact that if I reverse it, I'm correct? That's what I'm saying to you. Know? I reverse it is correct. Accept that. Is that like?
I have to write it out like it doesn't just.
Yeah, I agree. You should write down. I purposely don't write down. I purposely don't. Right now, the other way to think about this is I'm just integrating u du. Maybe there's one way to do it because when I integrate u, I will get some sort of u square. That is what is happening here. That is what is happening here. Okay.
Fine.
Okay, so accept first, right? So why am I doing this? Because I notice this is u square and this is u square. So I'm now completely in u square term. Sounds very familiar with just now, right? Sounds very familiar with just now. Can you? So again, I'm seeing whether this is making any sense. So now I'm just going to pretend that this is now y. I mean, for lack of better letter, now this is 1 minus y square. Sorry. To the power of minus half sorry, not y squared, y, right?
What?
Y dy, right? For lack of better letter, then I will use. Okay.
Oh man. Introducing
Now?
another term.
Yeah, I just use another term,
I
which
think
I
we're
will
two terms
now.
deep.
No, I think it's done. I will now revert it back to x to help you think. It is important to help us think, right? I'm now reverting it back to x for the sake of thinking. I'm trying to untangle your knot. Okay, Ken? Now we have x here. Ken, we just pretend. Okay? We just pretend. You like x better than y or u or w. Fair. Can you do this or not? If you cannot, then we are chasing the rabbit. But if you can, our problem is solved. Can you? Can you do that? Can you integrate that?
Yeah.
Please do. If you can, please do. Please do. Because you're no longer dealing with y, just x. Give it to us. Do it in paper. Yeah, do it in your paper.
Oof. Isn't that just like sine inverse?
You
Half
nonsense.
sine inverse.
You nonsense. You're just full of nonsense. You're just full of nonsense. That's not true. That is not true at all. That is you're forgetting something very basic. I'm going to rewrite this in the best way possible.
Oh, there's no x squared there. Oh,
yeah, there is no x squared there. Yeah. So
okay.
you don't think about sine inverse. You don't. You're just going to write down here, right? Just going to write down so that you can remember, right? Hopefully that there's a 1 over. This is a 1 over thingy, right?
Yeah, let's just do that.
Yeah. And the 1 over is a very big clue. I'm like hinting.
Oh, isn't it just like ln?
Yeah, you should be using it, right? So go ahead.
Okay, give it a second.
Yeah.
I might need to look at that. Let me write it down first before I switch back.
Yes, please do that. So far, is the switching back and forth bothering you?
I can switch back quite easily, seeing as my phone's right in front of me.
All right. Okay. Which is just what I hope. So you do that.
Give me a sec.
You 3 minutes to do it. I have to go to the bathroom, right?
Yeah, okay. So this is now inverse. Oh boy. Half times 1 is half, so half needs to be on top. So if half needs to be on top, it's 1/4.
Okay, I'm back. Right.
That was messy. Can you see it?
Now I'm seeing it. Yeah. Okay. Yeah. So you are doing the. Oh no. The root should be gone.
Really?
Yes, the root should be.
Oh,
Let me
wait,
just
let
show
me
it.
think. Did I do something wrong?
Yeah, the root is not to be there. It's not supposed to be there. Wait. Let me think first. Let me think first. Because you change the half into 1/4. So I was assuming that you already.
Because
You
if I want
already.
to learn it, the differentiation needs to be on top, right?
Yeah, so I'll show it to you. So again, this is the important part. The differentiation to ln is a very integral part. So I'm going to do it this way. So are you looking at my Jamboard?
Yeah, I am.
So I'm just assuming it's half, not minus half, just for clarity purpose. So again, this is 1/x to the power of minus half dx. Okay.
Wait, what? 1/x to the power minus half?
Wait,
Isn't
half,
it just 1 minus 1 over?
half.
Okay,
Sorry,
okay,
half.
okay, okay.
My mistake. Right? Okay.
Wait a minute.
Correct.
Yeah, okay.
Can, right? Can it make sense? Can?
Yeah.
So now I can integrate, right? So I'll integrate this as again half. This will be my ln 1 minus x, right? 1 minus x with yeah. Wait a minute. I am currently not sure. Yeah, let me think. Correct. There should be a minus here. With a 2. Right, so that's my answer, and all I'm going to do is I'm going to differentiate that, right? I'm going to differentiate that. I'm going to rewrite here. I'm claiming that the answer is minus this. I think my 2 is wrong. I think my 2 is wrong. I think my 2 is wrong. So the half is inside. So how do we differentiate this? If I differentiate that by ddx this, if I ddx that, then it will become, again, minus 2 doesn't matter. So what will happen? Okay. Wait, did I get it correct? Maybe I. What's going on? I'm wasting your time. Let me check something. I'm wasting your time.
Yeah, okay.
Let me check something, then we'll go back to this. Right. So you'll be satisfied once you find out whether this is true or not. In the meantime, I will invite you to look at your year's answer key and compare, see how they do it, and that's your revision. Right?
You mean my own answer?
Yeah, your own answer. What happened back then? Right? Because we're not using part 1 at all. Maybe your question is using part. So maybe that's easier. Maybe. We'll see.
Let me see the answer key.
Oh yeah, it's not supposed to be long. I'm thinking about chasing the rabbit hole here. Totally chasing the rabbit hole.
Yeah, the answer is half e2x sine inverse e2x plus 1 plus bracket plus half bracket 1 minus e to the power of 4x.
I mean, yeah, I know that's the answer.
To the power of half.
The process is what's important. So what's the process? Can you understand? I'm not seeing it right now. I'm doing.
Oh yeah. I'm looking at my original answers. I'm looking at my original answers.
So see whether it makes sense to you, right? Yeah. So I am totally wrong just now. Yeah, should do that. Yep, totally. Yep. And yeah.
Let me see if I get this.
Right. Okay, good. So I believe this is the answer.
I mean, like
the answer is minus 1. Right. So minus 1 half. If I differentiate that, that would be
because I think it could be made a lot simpler.
Yeah, correct. Yeah, solve
I think it could.
Yeah, sorry.
I think it could be made because I because in my original answer I used part A, right?
Yeah, correct.
So I convert everything down here, and then it became this. The integral that we were solving just now, which is this one.
Yeah.
It became like that, right?
Yeah.
So I had the answer here already, which was this the
Ah.
answer I got in part 1.
That was the reason why. That was the
So
reason why.
if I did, so I guess if I did a part 1, then we could have used
Yeah,
this
totally
one,
agree.
But I
Totally
have to
agree.
figure out like how to
Yeah.
what happened to the
Right.
why is there 1/4 here?
Correct. Again, totally agree with that. Totally agree with that. Because in exam you should be doing your original approach. You should, like you should stick to, okay, I think there's a big hint here, I want to use it. For this side, yeah, I managed to solve for the thing.
I think as practice, it would be good to like, it's still good to go through it as though I didn't have part 1, because then I can practice using this.
Well, it is another step, it's another approach that is useful in another question, I would probably say, right?
Yeah.
So I did solve it. There is no lawn here. So if you just want to look at the Jamboard. So,
yeah, give me a second.
Yeah, my mistake. Why am I thinking about lawn when it is power minus half, right?
Where do you write the answer?
So basically, this thing is just this thing, right? So it's just one.
Which thing is which thing?
Page 2. Sorry, page 2. Are we at page? Are we page 2? I'm
at page 2, but I don't see your.
I'm laser pointing something, so it's probably not working again. Probably not.
Second. Let me restart Jamboard. Okay.
Yeah. So I think you can see it.
Okay. Yeah, I can see.
Right. So I was here, right? We were here, right? We were here.
Yeah.
And then I simply make it to power minus half. Foolish me, that should be what I'm doing, right?
Okay.
Right. And then to integrate this as a simple method, like the half is here, right? So it's just this thing to the power of half lah, because from minus half you go to half, right? Simple.
Yeah.
Right. And then I have the minus 2 here because of this thing, 1 over minus half is minus 2 lah, right? That's what I get. So half times minus 2 that, again, follow me first. This is simplified. So my thing is I integrate this, I get minus 1 over minus x to the power of half. That's what I'm saying. I'm not just saying that. I go and prove it lah. How do I prove integration? I simply differentiate though. Fair enough, right?
Wait, hang on. Why is there
minus 2?
Yeah, why is that a minus? I get the 2.
Yeah.
But like,
yeah, because it's 1 over minus half. 1 over minus half is minus 2. However, I'm not asking you to trust me. I'm simply asking you to see the differentiation back. That's all I'm asking you to see. Okay, right? So you look at it and see whether it's correct or not. Then you can figure it out lah. Because why figure this one out if it is wrong, right? So here I differentiate this back. That's my claim. I differentiate this back, correct?
Yeah.
I differentiate it back, then I will have my original minus again. So let me just help you with that. My original minus is here, right? This one 1 minus x will now be, instead of half, will now be minus half, right? That's what we have, right?
Yep.
And then what happened to the half? The half must be here, right? The half comes from there, right?
Half comes from like the bringing down the
like
half.
Bringing down, right? Must be. And then where does the minus 1 come from? The minus 1 comes from here, the minus x, right?
Right. Oh, okay. Then that's why.
That's why.
Yeah, then that's why the minus cancel each other out.
Correct. So I believe I'm correct based on this, which is something very easy to do. You will do this in 10 seconds, and you will be very happy to do this in exam. I strongly suggest that you do. Minus is a big problem in exam. Yeah, we're just human being. You should always do this. So I rest my case, Ken?
Yeah, okay.
So remember that previously it is not x but y. So now everything here is y. Just return back to y, right? Just return it back to y, which is now 1 minus, what is y? Y is a u square,
U
right?
square.
What is u square? This is u.
E to the
This is
power
u.
4x.
Ah, don't think that's a coincidence. It looks very similar to your other method. Fair enough, eh?
Yeah, okay.
So it doesn't go very far. The answer seems to be like the exact same thing. You should just apply it by yourself if you're interested, because again, I think this method is not fringe method. It is a very useful method within questions.
All right.
Okay, that will be our revision. Go ahead.
Oh boy. Minus left.
Once you're done processing or rather accepting this, there's one more thing to do. Please tell me. Don't take too long.
Yeah, okay.
Okay.
You need to.
Because I cannot see what you're doing, so you must tell me.
Yeah. I'm trying to figure out all the steps by myself without looking at yours.
Which will be nice. Which will be nice, right? But you need to see at my Jamboard, so I cannot see you work. Oh, yeah. There is a weakness. There is a weakness lah. There is a weakness. Yeah. Not your fault. So I know the weakness now, right? And it will be a hassle to switch back and forth at this point. Yes, definitely not. There are some.
Mine, okay, I'm having trouble with, okay. Bracket negative 2, -2, yeah. -2, 1 minus y to the power of half equals to u sine inverse u plus plus 1 minus y 1 minus y to the power of half plus c. Wait a minute, what? I'm just gonna swap back to give me a sec. Am I? Okay, wait. I want to integrate it, then it will be. Boy, difficult one. Okay, wait. Calm. Integrate up. It will be half. Power half. So I bring it down, the half will be in front, but I don't want that there, so there will be a 2. There will be a 2 and then 1, so it'll be minus. Did I
I cannot see.
Yeah, I swap it back.
Okay, right. So you're saying?
Right. Did I make a mistake in this integration?
Yeah. Oh, you're trying to complete everything, right? Okay, yeah.
Yeah. I'm trying to redo it myself. Did I make a mistake with this integration? I don't think I did.
Because so your u sine inverse u should be correct, right? Your u sine inverse u should be correct, and then the minus half of that, which is what we're doing, right?
So
then
so ignore the half first. Like this, the integration of 1
That
minus y to the power negative
will be
half
minus
be
2. That I agree.
minus 2. Yeah, okay.
Could you move to the right a bit? Sorry, the paper. No, I'm sorry, to the left. I'm sorry. Yeah, okay, thanks. And that is power half. Yeah, I agree with
Then
that.
after that, I resolve it like that.
Because
then
it's a minus,
multiply.
then yeah, I think that's correct. I think so far, I think that's correct. And when I check my working, basically, I would agree with you. Yeah, I will agree with you.
Yeah, okay, but
I think then you return back to the u and the y, right? Okay. Because at this point, it's very easy to compare, right? The u is e to the power 2x, right?
Yeah.
You are missing the half. That's the only thing that you're missing. You're missing the half.
Yeah. Yeah, I'm not sure where the half
went. But the rest is the same, right?
Yeah, the rest is the same.
Yeah, I'm not saying that that's good. I'm saying that can you solve that later? It seems like a very minor, careless mistake, not to be ignored, but maybe later, maybe.
Okay.
Maybe later. Right? Yeah, I mean it's not such a bad result. You just have to find the mistake, right?
Yes.
Okay.
Okay.
Right now, remember we are in the process of reviewing. You just reviewed 2 questions, 2 very difficult questions, right? You learn something in the
did it in a different
ways, right? So you kind of press your brain, which is not a bad thing to do right now. I think that's a good review plus learning. Now, if this is a review plus learning, you may want to jump into a new question and test your review, because I think your review is substantial. If you think review is a redo everything I did, never mind, no need to do review. That's not a review. That's really not an effective nor a fast review. You don't have the luxury of that time or energy anyway, right? Yeah. So before you go to that, just have a feel of yourself right now. You're claiming that this is your high energy slot, right? That's what you're claiming.
Yeah.
So that's why we're doing tuition, right? Now, in tuition, I'm hoping that your sense of right and wrong, right, and your sense of good and bad is active very well, which I believe you are right now. Because to learn something new, you have to be able to tell, okay, I think I'm doing the right thing, I'm not doing the wrong thing, I think I'm doing something good, not something bad. You're pressing your brain in that manner. So far, so good, okay?
Okay.
Revision is the same, right? So you probably won't have much energy left. How many more hours or minutes can you stay in this good and excellent mode? How many?
I'd say I'll be pushing it if I keep going for another hour.
So half an hour or 40 minutes. That will be at the point where your energy drop until the point where you shouldn't be doing something new.
Yeah, so after tuition ends, then
that's it.
Right. After an hour.
In fact, tuition already ends 9:30. Right? Almost.
Not yet.
Okay. I mean, but you can push along another half an hour. Let's say you push until 10, let's say. And then after that, you are not to do anything new. You can't. You can do something you already know you want to practice more. Not something that, for example, a revision. If it is a very difficult revision, that is probably not considered doable after 10. Make sense?
Okay.
So after 10, if you don't do anything new or don't do anything difficult, if you just do something easy, right? That's not procrastinating. Do you understand or not? If at this point until 10, pushing it, right? You're pushing it. You don't do something difficult or new, like a new question, you can consider yourself procrastinating. So like I'm going to shut down this Zoom soon, right? Let's pretend we're in a very strict schedule. You don't push until 10, you don't try to do it in this half an hour slot, then you are procrastinating. You're procrastinating your high energy. But after 10, if you stop doing the hard things, you are not procrastinating because your energy is low already. No point. Have that idea that this 1.5 to 2 hours is very valuable, and therefore we're using it for the most difficult thing. I mean, this feels difficult for you, correct? And you're learning something new. You're not just slogging through, correct?
Yeah, I think so.
So half an hour more, you take a risk, you do a new question, choose a new question right now. Choose anything you want. Choose maybe 1 or 2. If you can do 2, that's nice. If you can do 1, that's great. The one that you say you cannot do at all, right? You're saying that I cannot do this at all.
Cannot do at all.
Like I don't know which one. Don't choose too hard, lah. But choose something. Just choose something, lah. You're saying that I don't understand all this, right? Maybe you understand something. Right? Choose one.
I think it was question 2.
All right, and question 2, 2A, is it 2A?
Yeah, 2A. I guess I could do 2B.
Maybe 2A or 2B. Even doing 2B, I will argue if you can successfully do 2B, that's substantial. Okay, I must say that 2B is, I suppose, similar to what we used just now, right? So that's not bad. That's not bad. It's a prelim question. Whoa, right? Whoa, right? Okay, so up to you lah. You want to do A or B? I still have 1 more minute with you. What kind of hints do you want? And then I'm going to cut off the Zoom, right? Cut off the Zoom, and you're going to last until 10. And then you got to stop doing something. Understand?
Okay, I think let's try B. Saying yes.
Okay, so I'll just follow you. I'll just follow you.
I need fresh paper.
Right. Now, this one you may want to do in a fresh paper. Right? You may want to. Right?
Tangent inverse e to the power of negative 3x.
Again, let me repeat. You are in the middle of revision, right? In that sense, but you're trying to apply your revision. So you should be looking at your previous revision if you need to. You understand? You should not deprive, because this is still something new. You still should do that.
So I can see immediate similarities with just now's question.
So can you apply something? Right? What can you do here? What can you apply? What can you, what can we do?
You can change it into the E3x into a different form.
That's not how I started. I'm proposing you that you start with a guess of U, that somebody will be nice to be a U. I'm starting with that.
No, in this case it'll be e to the power 3x, right? Because
minus 3x. Minus 3x, you mean, yeah? Minus
but like
minus 3x.
Negative.
Go minus 3x. Yeah, I know, but go all the way. E to the power minus 3x is U. If not, then it'll be useless to you. Because then you cannot write tangent inverse. You are just not confident, or you forget the fact that it is going to be very easy. So just trust me first. You just trust me. So U is that. Don't write equal. You're not focusing on equal at all. You have to set yourself up. You have to set yourself in a way that you have to write U is equal to. No. Stop. On the right hand side of the first line. On the right hand side of the first line, write down your setup. U equals to my e to the power minus 3x. You're setting yourself up. Then you want to find du dx. You're setting yourself up. Set it up. What is du dx?
Minus 3.
Yeah, go ahead. Yeah. Okay, rearrange this into something that you can recognize. And when I mean something that you can recognize, hopefully something related to e to the power 3x dx, hopefully lah. If it doesn't relate, then it's a bit bad, loh. It is a bit bad if you cannot relate.
Okay. So that means like that and like here. No.
Nah, it cannot relate. It cannot relate.
But like, yeah, because there's a negative.
Yeah, that's 1 over 3x. Yeah, unrelated.
What do I do?
Cannot relate.
Okay. But this is inside the bracket, so
yeah, cannot.
But do I just if this was
you should try something.
This was you do e to the power 3x, then I could just
try
then
it.
I could do the remaining.
Yeah, try. So don't. Oh yeah, you can do that. Yeah, fine. You can cancel that. So let's see whether we can relate.
Then 3e, so that means
So
1/3
that
of
means
du.
yeah, 1/3 of du is e 3x dx. All right, let's try that. Because then you probably have some problem inside the tangent inverse, but you know, who knows it is solvable, right? Now only at this stage you return back to the second line. You understand? Not? Only after you prepare yourself then you return. If not, it's very confusing. You're trying to do something very confusing right now, just now, by not preparing. Do you understand what I'm saying? Right. So now you return to the second, and then you can write something useful, probably. Yeah. At this point, you can probably write something useful. Yeah. That's
the du will be at the back later, but for now,
no problem. There's no.
For now, just tangent
inverse, right?
Okay.
1 over u lah.
E to the.
Whoa, what talking about?
Yeah.
1 over u.
Which? Yeah, I was gonna. Yeah. Okay.
Yeah, which might or might not be a problem, but you know, let's deal with that for now lah.
Tangent inverse 1 over u du. That's simpler.
Right, that is simpler, but can we handle this? Can we handle this?
Not that. I don't know the integration of tangent inverse.
Okay. Which is a very good thing to review, right? You can just take a look, right? Because this might be a problem. This might definitely this might be.
So there's no formula for tangent inverse.
There is a formula. No, but differentiation there is differentiation.
Differentiation there is, but you know, integration there isn't.
Correct. Which is part of the problem. Expected.
Let me look back. Can I?
I mean, write down something first, I suppose.
I need to look back at some of the older stuff.
You should have the list. By the way, I believe it is an MF26. Do you have your MF26?
It's online.
Yeah, so you Google MF26 and you look for differentiation of tangent inverse x. Right? Yeah, that's how you save time in your prime time. You're in a prime time now. Don't waste it in such a way. Okay, remembering things. Don't do that. Right, you're wasting your prime time.
Yeah, MF26. Okay, got it. Yeah. Okay, tangent inverse 1 over 1 plus x squared.
Okay, that's nice. Sure.
So that's the differentiation of tangent inverse, right?
Yeah.
Not sure how that helps me.
But it's something.
It will.
Something.
Okay, so let me just write that down.
Yeah. Your space on the right is your preparation space. You should use it like that. Yeah, you should. Because you're a person who likes to see everything at this place, correct?
Yeah, I guess.
So you should do that. It costs you 5 seconds to write. 5 seconds, and it helps your thinking. Good.
Right. How will that help me?
You are not comparing with the previous one. You're wasting too much time, right? You should be comparing and see, okay, maybe I can apply something. Maybe, maybe what did I do? What did I do just now?
Look back at the. Try to look back at.
Yeah. No, please don't try to not look back. Please look back. Please look back.
Yeah, I'm asking which one should I look back at?
You have to figure it.
Wouldn't it be? You have to be. It will be the sine x square one, right?
I I'm very confused with the way you look back. You're saying that this is similar to something, right? Okay, similar doesn't mean, the same, but this is similar to which one? There's only two questions, right? Each
Yeah.
has two approaches. So are you talking about question 10 or question 11?
I was thinking
Yes.
question 10 cause it was trigo, but now I'm not so sure. Cause like I'm looking
But
at it.
how can that be trigo? This is inverse trigo,
Yeah.
Inverse
I mean,
trigo and
question
trigo is
11
different.
question 11 had inverse trigo.
Yeah,
I
trigo
guess.
and inverse trigo is different. What you must at least acknowledge that.
I guess I could do what I did before. So
Which is at this step, what will you do? You will probably do a liate lah, right? A reverse product rule. Maybe that will help. Last time it helps. We should at least try lah, right? We should at least try.
should I change you into something else? Because
at this point, what would you do? It is very simple already,
I think I should.
Oh, as in the yeah, should use W or something. You should. If it doesn't confuse you, please use W or whatever, right? Whatever you want. Right. So the W will then. Why are you still using U? I'm sorry. I thought you want to use W.
Oh, am I not zoomed in?
Oh, you did. I'm sorry. Great. Which is no. If no. Don't change the 1 over U to Y. You don't do that. Don't do that. You cannot do that. You cannot. No, you cannot do that. Just use 1 over U. Right? 1 over U, and you want dW du lah. You want that. Right? You want that. Yeah. Right?
Oh yeah,
it
doesn't matter much because
it doesn't matter. Yeah, it's actually more confusing if you use 1.
1 over 1 plus 1 over U square. Ugh. And the other one would be
and you are wrong. Your differentiation. Not exactly wrong, but you are wrong. And unfortunately, differentiation a bit harder to. Come on, you didn't apply the chain rule.
Is there chain rule here? Oh my god, there is.
The 1 over U. The 1 over U is the
1 over
issue.
U is U to the
power of -1, right? Power of minus 1.
So times times negative U to the power of minus 2.
Yeah, thank you very much. Yeah. No need to simplify it. No need to simplify it. Don't touch it. Just leave it there. Right? Just leave it there.
dv du is equals to 1/3. So V will be equals to 1/3 U.
Yeah. Now, let's pretend that I will quit right now. So I'm going to give you some tips during this next 20 minutes, okay? Okay. Even if you press on and you don't get the answer, that's not the worst thing.
No.
Because if you press on and you don't get the answer, you have a question in mind. In fact, you may have some questions. For example, actually, am I chasing down the rabbit hole? Or you may narrow down into, I only have a very specific part that I cannot do. I can do a lot already, but I have a very specific that I cannot do. That's a very good question. That should actually give you a sense of accomplishment, even though it's not total. Because if the teacher discusses, you can zoom into that part already because you have a specific question in mind. It's not just, how am I supposed to do this? That's not the question you have anymore. Even if you press on, the next 20 minutes, you cannot get it. Do you understand? Do you understand what I'm saying?
So even if I don't get the answer, I have questions.
The question in your mind changes from how am I supposed to even start this question? You are no longer asking that.
I'm asking something more specific.
More specific or more narrow or more experienced is probably the word I want to use. And experience can be you fail or you succeed, but it is a more experienced question, which is definitely what you want in exam. You want to ask those kind of questions. You want to get used. Fair enough? Understand?
Right. How
do you feel about your review so far? Before I leave you, bye. How do you feel? Is this a review?
I think so.
How does it feel?
I think it's been useful. It feels like I'm learning something new. So
Right.
you know,
And using something old, which is what a review is supposed to be, right?
yeah.
Therefore, from now on, your review should be approached, I feel, should be approached, and it should feel like this.
Hmm.
Right? This might be a bit different from how you think a review should go last time, right?
Hmm.
But your feeling doesn't lie. You don't lie to yourself that much. You're not very good at lying to yourself. You probably are not that kind of person. Probably not. Okay.
Right.
So I'll leave you and I'll see you next Monday. But remember, you'll be studying at the same time tomorrow, right? Right? Remember?
Hmm.
And then on Friday, what will you do?
Friday I have another tuition.
Then what kind of tuition?
Oh, physics.
Friday is your worst day, which is
Friday
probably
is like, I mean, I'd say, you know, do it on Friday, so I have something to look forward to. So I try, so I'll push through the tuition, you know.
fine. But on Saturday, your father already agree. Your Saturday is, for rest, please.
Hmm.
Okay,
Yeah.
rest, please. Do something refreshing to yourself. I don't mean play all night. I don't mean that. You can play, but refreshing. And then on Sunday night, we don't meet on Sunday night. What do you usually do? What do you plan to do?
I mean, I get ready for school, I guess.
I suppose because school is on Monday, is it? Something like that.
Yeah.
And on Monday night we will meet.
Hmm.
This is my expectation of you on Monday night. I expect that you know the topics, the upcoming topics. So I expect you to know the future. That's one thing from the school, right? Obviously. Secondly, I expect you to be fresher than today. Today you're fresh. I expect you to be fresher than today. Why?
I mean, I guess because I don't know why I had school. I mean, that's just,
No. Because you have rested. Not
that's
yesterday, but you have rested on Saturday up to Sunday morning, maybe Sunday lunch. You can start studying after Sunday lunch. You don't have to study every day. Please don't do that. Your father disagree with that. Today you're fresh. So on Monday, you should be fresher. You only had one day of school.
yeah.
Right? Hopefully, you
I'm
can
fine.
meet my expectation. Hopefully lah. So on Monday, I'll see you. And you should be able to predict the future on Monday. And then we can talk about this again if you want.
Right.
I'll see you. And don't forget to stop until around another 15 minutes. Do something easier after that. Okay.
Okay.
Bye.
Bye.